Mistral recently introduced their new Agents API, showcasing its potential for multi-agent capabilities, which they showcase actually on their news page. They even have a real-time demo actually. For example, they have this travel assistant, which we can have a look at. But my question is actually, how do they do that? Because it's great to have a showcase of the capabilities of the Agents API, but actually we don't have any example of how it is built. But instead of waiting around, I suggest we build our own. Ours will be inspired by Mistral's, but we'll be able to track any flight currently in progress. Are you excited? Let me get you on board. By the way, where's your boarding pass? So the first thing that we'll do is that we will create our first agent.py file. So let's do it. Agent.py. Then, once we've done that, we're going to import a few libraries. The first one being, obviously, Mistral. So we'll import Mistral here from Mistral AI, import Mistral. So what we'll do is that we will create a variable called API key, which will contain the API key of our Mistral API. So let's initialize the client of Mistral that will enable us to interact with the Mistral API. So client equals Mistral API key. Let's create the agent now. So the agent is created using first a variable called flight agent, and then you call the Mistral API. So you use our client.beta.agent, referring to the agent API.create. Then model, we specify which model we want to do, Mistral medium, 2505 I guess. We need to specify the description. So what is the description of our agent? It is a specialized flight tracking agent that automatically identifies call signs. So this description is quite exhaustive, but it's crucial so that Mistral's model can actually reply with accurate answers. So if we continue, there's other parameters that we have to initialize here. So we also have to initialize the name parameter, which is the name of our agent. So it is called flight agent. Then we have to initialize which tools. So the tools will be us developing that, but for now, the tools will be an empty array. Instructions are like so. Flight tracking agent that is specialized. So you can see that I have been quite exhaustive here, but it's necessary. That's because the agent will know better how to answer the query and how to call the tool and when to call the tool appropriately. So let's now code the tool. So we create the first file, which is flighttool.py. So I've actually already developed it, so go ahead and just copy paste that. We developed this tool called getFlightDataByCallSign. So what's happening is that we format the endpoint with the call sign that's inputted as parameter by the LLM, and then we do a GET request so that we can get the flight information. There is a few error handling here, but if everything is successful, then we extract the latitude and longitude for those, and we call our second tool, which is getLocationWithType. So what's happening in this tool? I'm going to tell you. So there is first this load CSV, which is actually loading a list of countries by latitude and longitude. And then we're just trying to match here, which is the nearest country based on the latitude and longitude that is inputted by our previous tool. Once we get the closest location, we'll just return a new property called flying over, and we will append that to the original response from the API. And we also have here a new variable called fetchFlightByCallSignToolDefinition, which is matching the format of Mistral AI and OpenAI, and it just gets an information about what is the tool doing and the purpose of the tool, and also gives the properties that are to be passed as a parameter to the function. We have everything defined, so there is one thing I need to fix, the function name inside of our tool definition here. All right, what we will do now is we will create a while loop to loop through the agent itself. So we will get from here, of course, the input from the standard input so that we can get this interaction with the user, and it's in the while true because we want it to be an infinite loop. We will continue here defining a variable that is called conversation beginning. So why are we doing that? Because the thing is, in Mistral, when you want to create a conversation with an AI agent, there is two very important methods. The first method is called client.beta.conversations.start. The thing is, there is a second one that is called client.beta.conversation.append. So this one initializes the conversation, and the second one appends a new message to the conversation. we don't want to call start at every turn of our loop. So we will call append if it is not the beginning of its conversation, but we will call start at the beginning of the conversation. So this boolean is for this very purpose here. Then we have to input a few parameters here. So first you have to input the agent ID. Very interesting. We also already have that. So we will just input it like that. Then the input variable. So input variable are just the first message of this conversation. So as you guess, there is only one element in this array. The first is a role, so it is like role inside of the conversation. And in this case, it's the user that sent this message. Then we have content, and we send inp, which is the input itself. So next up, what we have to do is to initialize a store variable. Basically, a flag that tells Mistral that we want the conversation context to be stored throughout the discussion. So then, if it's not the conversation beginning, then it will append a new message and not start a new conversation. So the append method has a different parameter called conversation ID. We also need to get that from our previous interactions with the model. We will store this variable in a new variable called recent conversation ID equals, and we will input that, but we will also fill it in the next statements of this while loop. And then you have the inputs. And the inputs are also the same thing as here. So we have a role, content, user, everything like that in an array. But we have to do something else. We have to call the tool when necessary. The only way to do that is to get the response from the agent. We have to identify whether that response is for a tool calling or if it's just a message itself. The only way to do that is to analyze what is the agent replying. So we will store a response variable here that we'll get later on. Just as a safety net, we will just initialize it right here. And we want to check the content of that response. So the format of Mistral API is actually well defined in their Mistral API documentation. It is just a JSON object. We have an output list. We take the last element and we check the type. And the type, then here it is function call. So what we're doing now is want to check if they are referring to a tool that is our flight tool. So if response.output -1 is actually get flight data by call sign, function result equals get flight data. And here we directly call the tool that we created before, json.loads response.argument. Next up, user function calling entry. It is part of a type called function result entry. And once we have that, then we will initialize it by tool call ID equals response.output -1 tool call ID result equals json.dumps function result. We'll also import our tools here. We kind of forgot it. So we'll import OS. Then we will import the flight tool. So once we've got everything here, we will reference a variable called recent conversation ID. We will initialize it as response.conversation ID. The next thing we need to do is to create a response variable again, and we will call client.beta.conversations.append stream. And you have a conversation ID that we have to pass again. And then you have to input. So the inputs will not be a message here per se, but will be the function calling entry that we initialized before. If we reference that into the inputs, it will get this result that we got from the API. And it will be able to create a response based on that JSON document replied by our tool itself. Since we're streaming the output here, we will do something like for chunk in response, then if chunk.event starts with message output, then we print any chunk returned by the model, chunk data content. Finally, we want to check if the response itself is a message. So because it can happen that the output is a message and not a function call. So if response.output.type starts with message output. So if it's a message output and not a function call, in this case, we've got conversation ID from the response itself. Then we will print out response.output -1.content. What we'll do is that we will initialize finally that it is not the beginning of the conversation. So we will do it as false. And the last thing we need to do before doing anything in the console is actually to input that method into the tools variable. Now we have initialized everything here, and we are able to launch our agent. So bear with me. Alrighty, so we're ready to call our agent. Python 3 agent.py. Before we do that, let's just get any flight that's currently running. So if we go here, and then we grab any flight, for example, yeah, this one, and we ask for its status. Where is flight? Nice. That's perfect. This is perfect. It's actually streaming the answer. It is providing a very extensive output about where is the flight at the moment. So yeah, you can say here are the details of the aircraft. And the flight VLG is currently flying over France. Let's take any other flight, for example, flying over Alaska. Is there any flying in Alaska at the moment? There's plenty. Let's continue. So if we do that, then we have that. And we say, hey, what about flight perfect. So the flight ASA 137 is currently flying over Canada. Is it really flying over Canada? Well, apparently it's the nearest country, according to our algorithm. Alright then, I guess that's close enough. Let's just try here with another example so that we can see how it keeps the context. Where is flight Tom 552? Perfect. The flight Tom 552 is currently flying over France. What kind of aircraft is it? And it says, the flight Tom 552 is operated by a Boeing 737-800. Maybe we can just check if the state is still preserved in our conversation. So we say, can you say it again, please? Perfect. The aircraft Tom 552 is a Boeing with registration number GTAWG. And I think we can call it a wrap for today. We've just developed our first AI agent with Mistral Agents APIs. So thank you very much for tuning in. And don't forget to subscribe if you liked it. And also, leave a thumbs up. Thank you very much, and I'll see you next time. Okay, bye.